Python versus Java style of declaring a variable. I have a couple of diagrams to make you people understand that how a Java style of declaring a variable happens versus Python style of declaring a variable. If you look at the first diagram where I'm trying to give you a clarity on Java style of declaration, there you can see a set of variables which have been identified by its type. That means when the programmer is programming the code, at that time itself, the variable have to be assigned with a specific type. And that's called as a static typing. So statically you have been pointed that this particular variable is going to be of this specific type. Further on, you don't have the privilege to change the value to a alternate type of that particular variable. Let's take an example. The first declaration is all about an integer variable, and that's been assigned to a value called 10. And now what happens here is, when the ivar variable is going to be accessed, you will have the access to that value called 10. But later, if you're trying to modify the value for the variable have to be modified only from the family of integer, but you can't suddenly change them to a family of string or a character or a Boolean or so. Why is it so? Because statically it's been defined that this variable is going to be of type integer. The same is applicable for the other variable which have been declared here. If you look at the character, if you look at the Boolean, if you look at the float, all these variables have been statically denoted that these are going to be of that specific type. Later you don't have any option to change the type of it. But coming to Python, it's more straightforward that you declare your variable and then assign a value to its variable. That's it you have to do. There is no prefixing of data type there. Why is that? Because Python is more of dynamic typing. So what I mean by dynamic typing is, during the compile time of a program, the variable need not be identified of what type it is. But rather, when it goes into the runtime, means when it goes into the Python interpreter, the interpreter will assign the type for the variable based on the value that's been assigned to that variable. So let's take an example here. We have a variable called ivar that has a value called 10. Now compile time, this means it's of type integer. Later, can I change the value of this ivar to a Boolean type? Yes, of course you can do it programmatically. So what happens is, dynamically, the type is going to be changed for that variable. So how altogether it works in Python is, a variable is declared with a value, and at runtime, the variable's data type have been assigned or identified based on the type of value that's been assigned to that variable. So let's quickly see an example for this. So I'm declaring ivar where I'm assigning it to 10 and I'm trying to print this value of this variable. By this way you get the output called 10. That's great. But the same variable at a later point of time, I can access it not only to access the value, but then I can modify the value of it. So let's say 20, and that's what variable is all about, as we discussed in the earlier session. Here, when I print this ivar, you will see the changed value of that variable. That's nothing but 20. That's pretty straightforward because the variable have been assigned to a type of integer family, and so we modify the value to that variable with the similar type of family itself. But what if in case I'm going to altogether change the value of this variable to a different family, like a character? If I do so, and if I try to print this variable, my Python interpreter will never intervene into this, assigning of a character to a ivar, because the nature of the interpreter is to ensure that the ivar is going to be considered a type of string, as in this case, because it's been initialized with that type of value. So let's execute this. See, now we get the output of h. So what it means that your interpreter is interpreting this variable type based on the value that's going to be assigned. So compile time check is not happening at all here, and so we don't call Python as a statically typed language. Rather, we will call it as a dynamically typed language. The meaning of dynamically typed language is the language itself is going to manipulate its programming code based on the runtime rather than compile time.